Hi students, in this video we are going to see the midbrain, the sections of the two sections of the midbrain. First let me draw. First you have to draw the midbrain like this, right? Like a tent. And here you have to draw one structure. And here you have to draw another one structure. And here is the tectum where you have the superior and inferior colliculus. That area is called as tectum. And here this is the region called tegmentum, and here is the region called crus cerebri. So this is how it is being divided. And now next thing is, just in this line you have another one dark color structure, that is your substantia nigra, right? Substantia nigra. And the most important one here is your very important nucleus present here is your red nucleus. So first I will draw the parts. Number one is the tectum, and below this the tectum only you have the two colliculus, superior colliculus and inferior colliculus. MCQ: superior colliculus is responsible for vision, carrying the fibers of visual fibers, and inferior colliculus hearing. Okay, so carries the fibers of auditory fibers. These two are MCQs, that is in the tectum. These are all present in the midbrain. So what we are reading is midbrain. And the next one is the tegmental part. In the tegmental part only we do have all the nucleus and everything. We'll see in next picture. And then next is here crus cerebri. In the crus cerebri only it will be divided into three parts. The anterior of 1/6 is the fibers from the frontal lobe of the brain. So frontopontine fibers are coming through this. And then here is the rest 1/6, posterior 1/6 for the occipitopontine, paretopontine and temporopontine fibers. So all these fibers are going to the pons. From the pons it will be going to the cerebellum or to the spinal cord, right? So these fibers. So in the what is there in the middle part? In middle 2/3 everything, it carries the fibers of corticobulbar. Bulbar means nucleus, cranial nerve nucleus. Another one is main corticospinal fibers. All these fibers are going in the middle part. So this is the MCQ. So MCQ number 1 is the superior colliculus. MCQ number 2 is the inferior colliculus. Number 3, which part of the crus cerebri carries the corticospinal and corticobulbar fibers, that is your middle part. And the next important MCQ is substantia nigra. So what is substantia nigra? What does it contain? Substantia nigra and the red nucleus, both are important questions. So we will read the nucleus. In the nucleus we will be reading about the substantia nigra and the red nucleus. Anyway, red nucleus, why it is called red? Because it contains iron containing pigments, and it has rich blood supply, so it is red in color. 0.5 millimeter in diameter, centimeter in diameter. And the next one is, it is a gray matter. The most important thing, first you have to write about this while writing. It is a gray matter which appears ovoid in shape and 0.5 centimeter, and it is situated dorsomedial. Look at this, dorsal to the substantia nigra. And in the first specimen it appears pink in color because it has high blood supply and it containing iron containing pigments are there. And what are the afferents and what are the efferents? So afferents means from there and all the fibers are coming. So cortico to red nucleus. Red nucleus means red, the otherwise called as rubro. So cortex to rubro, the fibers are called corticorubral fibers, and cerebellum to rubro, that fibers are called cerebello-rubral fibers. And the third one is your pallidum, globus pallidus. So from there the fibers are coming, that's why it is called pallido-rubral. And the next one is from the thalamus, the fibers are coming. So from the thalamus and the hypothalamus and the subthalamic nucleus and substantia nigra, and from the tectum. All these are afferents. At least the students write corticorubral, cerebello-rubral and globus pallidus. Subthalamic and hypothalamic you can write, right? Even the substantia nigra is nearby, so you can write that. Next is, what are the efferents from the red nucleus? Fibers are going to, so it is called as rubro. You should start with rubro. Here from where and all the fibers are coming into the red nucleus. So it is from the cortex, from the cerebellum, from the globus pallidus, like that it will go. Efference means from the rubro fibers are going to the spinal cord, so it is called rubrospinal, and from the rubro the fibers are going to the cranial nerve nucleus, so it is called rubrobulbar. And then third is from the red nucleus rubro to the reticular fibers, so rubro reticular, these three are the main fibers. And the next is this is about the red nucleus. So if the short note is asked, these are the salient important points you are supposed to write. The next important point is the rubrospinal is very important. The rubrospinal tract, this tract they decussate means they cross and forms ventral tegmental decussation. We will be seeing what is it, ventral tegmental decussation, the rubrospinal fibers. This is very important MCQ. So very important MCQ. Rubrospinal fibers decussation forms the ventral tegmental decussation. And the next is rubrospinal fibers only, that's the action is they are responsible for the control of the flexor muscle toe. So if it is paralyzed, it may lead to tremors. Okay, this is one of the important extrapyramidal system. And now we are going to see the superior colliculus and inferior colliculus level. So I will draw the superior colliculus level here. Like this, you have to make a box, and this is the midline, and here also I will make the this is the inferior colliculus level, and this is the superior colliculus level. So you have to come down, and then you have to draw like boxes, and then put a midline here, and then you have to draw the crus cerebri, three parts. In the middle part only corticospinal and corticobulbar tracts are going. And then the most important is here superior colliculus. So here you have to draw the aqueduct, and here also I should draw the aqueduct. Okay, we will draw the aqueduct here, cerebral aqueduct, and here I will draw the superior colliculus. Okay, so here I should draw the inferior colliculus. Okay, right. So inferior colliculus means midbrain means third and fourth cranial nerves. So inferior which cranial nerve? Fourth cranial nerve, and superior colliculus third cranial nerve. So I should draw the fourth cranial nerve here. So first we will finish off the third, and then we will go to the fourth. Okay, so third cranial nerve is your the most important nerve is called as oculomotor nerve. So I will draw the oculomotor nucleus here. Next, the border you will be having the medial longitudinal fasciculus. Something called as medial longitudinal fasciculus is attached here, and then here you have another one nucleus, pretectal nucleus, and then here you have to draw the mesencephalic nucleus. Understood? So these many nucleus I have drawn. From here oculomotor only, and the most important, nicely here I should draw something in the pink color, that is red color or pink color. What is that nucleus? Yeah, it is red nucleus. I have drawn the red nucleus. From here the oculomotor fibers they come through the red nucleus, right? Okay, right. And then here I am supposed to draw the lemnisci. So I will draw the medial lemnisci, trigeminal lemnisci, and the spinal lemnisci. Okay, here also I will draw the medial lemnisci, trigeminal lemnisci, and spinal lemnisci. And then next is the decussation. I will draw the ventral tegmental decussation and the dorsal tegmental decussation. And then here reticulospinal spinal tract from the all over the brainstem you will be having the reticular fibers. So all over you have to draw the reticular fibers. So here also I am drawing the reticular fibers, which is responsible for the awakeness in the human being, right? Alert, awake, everything is because of the reticulospinal. So we need this. Understood? Okay, what is this ventral tegmental decussation and what is this dorsal tegmental decussation? Ventral tegmental decussation is by the tract called rubrospinal tract. They decussate, they cross and forms the ventral tegmental decussation. Dorsal tegmental decussation is by the crossing of the tectospinal tract. Understood? Tectospinal and tectobulbar tracts. They tectobulbar and tectospinal. What is this tectospinal? It is responsible for vision. Those tracts they come from the tectum of the midbrain when they go to the spinal cord, immediately after coming out it decussates and then it goes as tectospinal. So this is called as dorsal tegmental decussation. This is a very important MCQ. And then here I have drawn the medial lemniscate, trigeminal lemniscate, spinal lemniscate. What about the lateral lemniscate? This is superior colliculus level, right? Superior colliculus means it responds for vision and the visual fibers, and here inferior colliculus responds for the auditory. So what happens, let me stop this video in this and then I will continue. More than 10 minutes video. Okay, let us continue. Okay, so visual fibers and it carries the auditory fibers. Next important thing, what should I draw is this superior colliculus level is for the vision. Then I don't want the lateral lemniscate, because lateral lemniscate is a decussation of the cochlear nucleus. So cochlear fibers means it is for hearing. So it goes to the inferior colliculus level. So lateral lemniscate ends and forms at the inferior colliculus level. From there it goes to the medial geniculate body. No need to come here because this is the visual area. We don't want the cochlear fibers. So lateral lemniscate you should not draw. Understood? So only mean 3 lemniscate. Red nucleus already we have seen. One more MCQ is there in the red nucleus. Red nucleus is traversed by one nerve, that is your oculomotor nerve. And another one MCQ, between the two medial part of the crus cerebri, which nerve emerges? Which nerve emerges? Yes, oculomotor nerve. This is also MCQ. So 2 MCQs here. And then here your medial longitudinal fasciculus is attached on the lower border of the oculomotor nucleus. In the oculomotor nucleus we have one more component. That nucleus is called as Edinger-Westphal nucleus. Edinger-Westphal nucleus is it's a very important parasympathetic nucleus. This parasympathetic nucleus, what is the role of this nucleus? So from the, I said no, pretectal nucleus. So from the optic tract it comes the visual pathway. It reaches the pretectal nucleus. From the pretectal nucleus it goes to the Edinger-Westphal nucleus. From the Edinger-Westphal nucleus is responsible for the light reflex and the accommodation reflex. So what happens? And consensual light reflex. So in this area you need to write something about Argyll-Robertson people. What is Argyll-Robertson people? Another one MCQ. Absent light reflex and preserved accommodation reflex. So that is a very important point in Argyll-Robertson people. Edinger-Westphal nucleus, how it causes right reflex? Edinger-Westphal people, through the inferior division of the oculomotor nerve, it goes and supplies the ciliaris muscle and the sphincter pupillae through the short ciliary fibers through the ciliary ganglion. So kindly note the ciliary ganglion pathway, and through that it comes and supplies this. That's why it gives the light reflex. And the same thing, accommodation reflex also, it is related to the oculomotor nerve. Because of the muscles they contract and then they form the accommodation. Okay, they gives accommodation. Then I will go the same thing here. I will draw the same crus cerebri, and then I should not draw the red nucleus because red nucleus is present only at the superior colliculus level. Here is the inferior colliculus level, and here also I should draw the mesencephalic nucleus, and here also I should draw the mesencephalic nucleus, and here I should draw the trochlear nucleus. Okay, trochlear nucleus, and here I should draw, instead of here only the fibers decussate. So already the fibers have been decussated, so the tracts I have to name their tracts. So that is your medial longitudinal fasciculus, which I have drawn here, has come out. Medial longitudinal fasciculus and the tectospinal tract and the rubrospinal tract. Okay, 3 tracts I have drawn in the middle. Okay, and the next is lemniscate, medial lemniscate, spinal lemniscate, trigeminal lemniscate, and lateral lemniscate. Here I am supposed to draw all the lemniscate, because lateral lemniscate only it is responsible for the audition. Okay, auditory pathway, because lateral lemniscate is formed by the decussation of the cochlear nucleus fibers. Understood? So which is very important in this area. So this is at the inferior colliculus level. So I have drawn everything, and the most important cerebral aqueduct type. What is this mesencephalic nucleus? Mesencephalic nucleus is nothing but the proprioceptive fibers from the proprioceptive. You are yawning, no? That time how your mouth is, that and all. So the proprioceptive fibers from the muscles of mastication, teeth, ocular muscles, and then facial muscles. All these are going through the mesencephalic nucleus. So the trochlear nerve is coming out through the dorsal part of the brain, okay, midbrain. So the only nerve which emerges out through the dorsal of the brain as a midbrain, as well as it immediately decussates and then it comes out. These two are MCQs. Immediately after decussate, before it comes out, it decussates. Understood? Very important, very important. Okay, that's about the trochlear nucleus. Trochlear nerve comes out. Okay, so immediately it decussates and then only it comes out. One. And number two is only nerve emerges dorsally is the trochlear nerve. And here is the MCQ. What I said is the nerve which pierces or passes through the red nucleus is your oculomotor nerve. And here you have the lateral meniscus. Here you don't have the lateral meniscus. And the most important, here you should draw everything separately. Here the what is that medial longitudinal fasciculus? This medial longitudinal fasciculus, if somebody calls you by the name, you will turn. So hearing was first important. So 8th nerve, and then you will be turning. So your neck is moving. So your 11th spinal axis is important. Then 3rd oculomotor nerve is important. Okay, and 4th movement, 6th also eye ocular movements. So all these nerves are interconnected by a pathway that is called as medial longitudinal fasciculus. So you have to draw the medial longitudinal fasciculus and the reticular formation throughout the brainstem. So this is about the two structures which is present in the midbrain, and the syndromes related to that is you have to write about the Weber syndrome and the Benedict syndrome. Weber syndrome is produced by the vascular lesion in the peduncle, cerebral peduncle, due to the occlusion of posterior cerebral artery. And what will happen if it is occluded? So cerebral peduncle means this is the area. Here this is the peduncle, right? So this is the area where it is involved. So imagine and tell me what and all will happen. So oculomotor nerve is involved, right? This is the Weber syndrome where the cerebral peduncle is involved, and this is the nerve. So oculomotor nerve is involved. So what will happen? Oculomotor nerve lesion leads to a squint. Okay, so it will lead to ipsilateral lateral squint, and then the corticospinal fibers are involved. So it is called as paralysis of the due to the involvement of contralateral hemiplegia. Okay, contralateral because opposite side it has to go and decussate. So hemiplegia will be there, and then next is here corticobulbar tract is involved. So it will be it may lead to contralateral paralysis of the lower part of the face and the tongue, and ptosis because of the oculomotor nerve. This levator palpebrae superioris is involved, right? So ocular muscles are involved. So you will be having lateral squint as well as levator palpebrae superioris is involved. So you will be having ptosis, and then the Edinger-Westphal nucleus is also involved. So the pupil is dilated. Understood? Usually what is the reflex of the Edinger-Westphal pupil? Pupil should be constricted. And the next is Benedict syndrome. Benedict syndrome is due to the vascular ischemia of the involving tegmentum part of the midbrain. So tegmentum part of the midbrain is this area. So we'll give some separate color here. So this area is involved. So this is here Benedict syndrome. So Benedict syndrome, what are the effects will be there? Squint again because oculomotor nerve is involved, and loss of pain and temperature because of the lesion of the spinal lemniscus and the trigeminal lemniscus, and then medial lemniscus is also involved because of the involvement of the medial lemniscus. Loss of tactile vibration sense, position sense, everything will be gone, and then tremors will be there. Why tremors are there? Red nucleus is involved, so you will be having tremors. So this is about the second application, and the third is Argyll-Robertson pupil, and it's very important, and it occurs as a lesion of the pretectal nucleus. So this is the pretectal nucleus. If there is a pretectal nucleus involvement, there will results in Argyll-Robertson pupil. Argyll-Robertson pupil, already I have told you, absent light reflex and preserved accommodation reflex. Understood? So these are the clinical applications you are supposed to write. That's all about the midbrain. If you have any doubts in this anything, you kindly please ask me in the comment section. Thank you.